Hi everyone. So I'm basically going to do some question about mock interview. So I basically choose question from the code, range from easy, medium, or hard. So let's start from an easy one. So for this one, I plan to solve it in 15 minutes. And also, we're gonna do this in a mock interview process. It's not like doing it in the LeetCode. So I'm gonna write it from scratch. Yeah, let's do it here. So the mock interview, we create a new file like here. Search insert position. Right, so we just write here. So for the question, it's basically not hard. It's an easy one. Hopefully I can solve it in 15 minutes. So this one is about, well, given a solid array of distinct integer and a target value, return the index if the target is not found. If not, return an index where it will be in order. Okay, so question. So given an array, sorted, given a target value, find the index or find where it should be inserted. Right, so this is basically the question. So you just follow the mock interview process. So after clarifying the question, we gotta do a test case. So if the input numbers like the array, so array is equal to, let's just write something 1 2 3 or 1 2 5 6, like the same one from the LeetCode. Target is equal to 5, and then return index is equal to, right? So another will be so 1 1 3 5 6. Now target is 2. Then we insert. I think we need to insert, right? Yeah, sure. So to insert, I'll put this 1. So I'll maybe just change some of the other numbers for the test case 3. So just put 3, 7, maybe 9, 0, right? Target is equal to 8, probably. Then we return the index. In this case, the index should be 0, 1, 2, 3, 4. So it's going to be 3. So here, all the test cases is here. And the idea is, so we're going to use, we can definitely do iteration. Just start from the first one, but it's not optimal. We're gonna do a one binary search probably, which give me O log in time complexity. So we're gonna do binary search. So I think say O log in. So we probably use the binary search tree. Not binary search tree, sorry, the binary search. So we're gonna do this. All right, so some constraints. So the things that I come up with is we need to have the length of the array. It's the first one, and we need to ask the the time complexity. It's definitely the second one. So we already have the O log n. Right. So maybe there's some constraint for the element in the array. So okay, so maybe some the target. Okay, so I think that's all the things that we can come up with about the constraints. So let's write some idea about how to coding. So step one. First, if we start from the middle of the array, and then we do binary search. So binary search is basically here. We do if the target value is larger, and then we're going to go left. Go to the left subarray, right? If the target value is smaller, and then we're going to go to the right. So we can definitely have not found. So we're going to do something about this one. So if it's not found, we return the next. Well, close it. Alright, so that's basically what we do. And the idea we implemented is we use recursion. Okay, cool. So again, we're doing mock interviews. So we actually write it from scratch. So we don't care about how the LeetCode doing it. Maybe we just write a function ourselves. So let's write the whole program. So we're using C++, by the way. And for this question, I'm not going to use iterator. I'm not going to use vector. I'm not going to use array. Some built-in libraries, STL. Just going to use the normal array, like the one in C. But we actually use C++. Using standard cout for testing. Using standard end of line. And probably we're going to have a function name int find target index. So in this function we're going to be passed. First we have an array. We will pass an array, and we definitely have a target value, and the side of the array also needed. Okay, so I think it will be helpful to define a helper function so that we can directly call the helper function. Target index is equal to, we call the helper function. Helper function, we pass into the array, target, and the size. We actually set size -1. And maybe we have some other parameters here to do. Oops. Okay, so here let's define the helper function. It could be pretty easy. Int helper For the helper function, no, we don't need this one. So we have array definitely, and target value. And for binary search, we can have in start and in end. So this indicates the position that we're going to look for the array or the subarray. So so the first thing we're going to come up with is probably the base case. So so the base case is when the target is equal to the array element. So okay, so we're gonna write function here. So we find the middle of the array, start plus end, and minus 2 divided by 2. So this line doing integer division, and then if the array middle is is greater than target, so what we're gonna do, we're gonna go left. Right. So we return helper array target, and can have this time we're gonna be careful. So start is start. Since we go left, middle should be -1, right? And else if, well, we actually don't need the no, we need the else if. Yeah, sure. If the array middle is smaller than target, so what we do this time, we return, well, I think we can directly copy from here. Yep. Okay, so this time we're going to go right. Right. So the middle, and then you can go straight to the end. All right. So else. So the else is basically means the array is equal to target. All right. So in this case, we return middle. Okay. So what if not found? So every time we decrease middle or increase middle, and we divide it by 2, and then the base case, not the base case, the not found will be here. We return the start value, right? Okay, it sounds good. And then we call helper here. So we have the start. The start is basically 0 this time. We write a helper function, and we write a size -1 should be size -1. Yeah, sure. That's the end. Okay. It seems to finish, right? Let's do a little bit of testing. So what if we write some test case here? We need to define array is equal to 1,356. So we're going to see out. We're going to print find. Call this function target index. So this function have 3 parameters. 5, 4. We're gonna maybe to make it easy, we just add a end of line here. So the second one will be we find array. Well, let's test a one that we test case that we don't have in array. So we don't have 14 in array. We're going to see. So for this test case, we run it manually. So it's 5 here. So for 5, we have the third element of it. Well, it's actually index 2. So we expect 2. For this tag, we expect 14. Not 14. The 4th, which is the end of the array, right? Okay, so let's run it. Hopefully we don't get it wrong. So g pass. Oops. Some non-void function doesn't have a return type. Okay. It's a line 60, right? Line 60. Okay. Oh, cool. Return target index. Let's recompile. Oh, cool. Index rerun. Oops. It's 2, 4. It sounds good. Oops. 2, 4. Alright, so I think pretty much we solved this problem in the O-logging time complexity. So let's finish this one here.